Hello everyone, welcome to another tutorial. In this video, we will talk about Atop command, a powerful tool for monitoring a system performance on a Linux. Whether you are a system administrator or a developer, this tool can help you to check your system CPU, memory, disk, and network usage very easily. Let's go through its features, options, and some real world example to see how it can help in your daily tasks. Before starting with Atop, let's understand what is Atop. Atop is a system monitoring tool that gives a detailed information about the system performance. Unlike tools like Top or Htop, Atop lets you monitor not just current resource usage but also log these information for later use. This is very useful when troubleshooting performance issue that does not happen all the time. Let's start by installing Atop on a Rocky Linux. I'm using Rocky Linux 9.5. You can easily install it by following command. Let's see the OS. I'm using Rocky Linux 9.5. Let's install Atop command using yum. I'm using sudo. That's why it prompted me for admin password. So once installed, you can run the command by typing Atop in the terminal to start monitoring your system performance. Installation is done. Note that Atop command is widely supported on many Linux distributions. If you are not using Rocky Linux, you can still install it using your distribution package manager. For example, on Debian based system like Ubuntu, you can use apt, and on older CentOS version, you can use yum. Since we are focusing on Rocky Linux in this video, let's move ahead with using it. To use Atop, just type Atop and enter. You will see the interface divided into two main sections. One is system matrix and another is a CPU process matrix. This is process matrix below, and above is a CPU matrix. System matrix. System matrix, at the top side you will see system matrix. You will find the system wide data like CPU, memory, and network usage. This helps you to understand overall performance. And process matrix are below the screen. You can see the process matrix. Left hand side you can see the PID and sys CPU, user CPU, everything is displayed. You will see the information about the individual process such as CPU, memory usage, disk, IO, and the user running them. For example, if your system is running slow, this output will help you to identify which process or a resource is causing the issue. Now let's explore some of the most useful options and how they can be applied in real situations. For example, if your server is slowed down at a random times, you can save the system performance data to a file and analyze it later. Let's see how we can do it. So for that we need to create a directory. I think I have already created. Let's check. Atop-log directory is already created. Let's run atop command -w and give the path where you want to save the log file of Atop output. I'm giving log file as the file name. It will save Atop output here. Press enter. It required sudo permission. So it started copying the data into log file. Atop does not exist with your when you press Ctrl C or Q while using the -w option, is that it is not running in an interactive mode. -w option writes the system activity data to a file, and in this mode Atop continues to record data until you terminate it properly. You need to terminate the process properly using PID. For that we need to take access of this server on another terminal. I have taken the access. Here I will check ps grep atop. So here when you run this command, this will list all the process containing the word atop. Look the file line running with -w option and note the PID and kill it. Once you kill it, go to the previous terminal and see if sometimes if it will not get exited, you need to use -9, kill space -9 and followed by the PID. So the alternate method, if you want to save the output of atop in a file, you can run using timeout. You can use something like timeout 60. Let's see if this works. -w, give the file name. Now I will give file1 sudo. After 60 seconds, it should get terminated automatically because we are using timeout 60 followed by atop space -w and where log atop slash log followed by a file. Here we are using log file1 as a file name. Let's check why it is not executed. This will take some time, or else to check if this command is working properly or not, let's kill it. Let me kill this. Before that it has been terminated. Okay, this command is working. Let me check. Let me run this with a 5 seconds and see if it works. It get close after 5 seconds. If this command is working. So here what it happens when we use -w, this command is not running in a active mode. So that's why we use timeout 60 seconds or timeout 5 seconds. For 5 seconds it will monitor and it will get recorded in this file. So let's see how we can recheck the log files. We will see this file. This we called as a replay a log with a top command using -r and give the file name and press enter. So here you can see if your investigation what caused high CPU usage last night means for our old data, you can replay the logs file to see what happened at that moment. Let's close this. And also you can set monitoring intervals like atop -d 5 and 10. This will monitor your system at a 5-second interval for a 10 cycles. Use this when testing how a specific application affects the performance. At that time you can use this. This will open atop. So like this we can also focus on active process by using -a option. Let's see that option, atop -a. This shows only the process currently using the resources, which is great during a heavy server activity. So this is the one option. Assume that uh, you want to check CPU memory like that. If you want to see the specific resource usage for CPU, we use atop-c. So all the CPU usage we can see here at the left hand side, and also it will show the process below how much percent it is using. And similarly we can see atop-m This will show the memory usage, and for disk we use -d. For disk usage it will show the -d, and for network usage we can use -n. Like this, we have multiple options in Atop. If you suspect a memory leak, use Atop-m to focus on memory usage and identify the problem process quickly. Like that, let's see what all options available in Atop. Run Atop, press enter. We can see Atop first line, Atop Rocky Linux, and followed by the time date it is showing. So this session shows the date and time when Atop was run, as well as the time since the last report. In this case we have 10 seconds. Here it is showing a 10 seconds. And next you can see PRC. Here this is a PRC sys, and the timing we will see one by one. What is PRC? Sys user hash proc hash zombie. All this we will see one by one. For sys, the total CPU time consumed by a system kernel process, that is 0.18. Now it is 0.8. And for user, this for this user, the total CPU time consumed by a user process, that is now 0.01 second. And hash proc, the number of active process. Zombie, the number of zombie process is one that has completed execution but still has an entry in the process table. And this last, this indicates whether the process counting is accounting is enabled. If no, it's not enabled here as of now, because it is displayed with no. And if we see the CPU usage, the sys is a system CPU usage, user is a user CPU usage, and the IRQ is the CPU's usage spent handling interrupts, which is displayed in a percentage. And idle, the percentage of CPU time that is idle, that is this can sometimes add up to over 100% when multiple CPUs are involved. Here I'm using a 4 cores, that's why it's showing 400, I think. And next is a wait. In zombie column you can see it's showing a wait. The CPU waiting for IO operation, it shows in a percentage. And below that you can see CPU 1, CPU 0, CPU 2, and CPU 3. The CPU usage stats per individual core. I have allocated 4 core for this uh, Rocky Linux. It is showing CPU stats per individual core, showing a idle time and a wait time for each core. And the next is CPL. Let's see what is CPL. Context switches and interrupts. Here it shows average 1, average 5, average 15. These are the load average over 1, 5, and 15 minutes. The load average indicates how many processes are waiting in the queue for a CPU time. CSW shows the number of context switch in the last intervals. A context is happens when the CPU switches from one process to another. And the next is the number of interrupts per second. This signals to the CPU from hardware or a software requesting attention. Next is the memory usage. Here you can see TOT is the total physical memory available. It's 4.5, and the free is 2.4, and memory used for buffer is 2.7 MB. Buffers are temporary memory used by a system to store a data. SLAB memory used by the kernel for caching. And the next is number of non-uniform memory access means node available in the system. It is 1. Let's see if we have swap TOT. It shows the total swap space, and the free shows the swap space that is free and not being used. It's 2 GB because it is not in use. And next is swap cache, amount of memory used by the kernel for swap data, and the virtual memory used here, it is showing 2.8 GB, and virtual memory limit, it is 4.2 GB. So similarly for disk also we can check. Here we have LVM and the disk usage. LVM details about the logical volume usage. It is showing RL underscore VBox hyphen root is the root volume, and it's not very busy with only a little writing happening. And here it is happening 4. And the DSK information about this one is LVM, and this is DSK information about the disk slash. Here it is not showing, but it has the slash dev slash SDA. It shows very low activity with 0% busy and only 2 writes happening right now and 0% busy. And the next is network usage. Here it shows TCP and UDP package information, shows the number of packet received and sent. TCPI equals to 9 and TCPO equals to 8, etc. Like this it will show. And the network shows the number of IP packets received, and this is the information about the network interface. ENP0S8 is the network interface for my virtual machine Rocky Linux. It shows very low activity with no package sent or received. In terms of speed, it shows 0 KB right now. And the process list at the bottom, you can see the process list. These are the process list. Let's see one by one briefly to quickly cover everything in one tutorial. Here you can see the PID is the process ID. This is amount of system CPU used by the process. And the next column is the amount of user CPU used by the process. And the next is delay in the process, virtual memory growth, and resident memory growth. And also we have ST, state of process, any exception or number of thread used by the process, CPU number the process is running on, and the percent of CPU being used by the process, CMD the command that started the process. In your example, Atop itself is using some CPU, and as well as the other process like Java, Kworker, and the VB service, VirtualBox service. I am running Rocky Linux on a VirtualBox. So let's talk briefly about how to read the Atop output. CPU usage checks which checks the process are using the most CPU and whether your system is under heavy load. Memory usage, just now we discussed. Look for the high memory usage or swapping, which can indicate a storage of RAM. And disk IO, high read or write number may point to storage bottleneck. Network activity, identify the process causing unusual network traffic. So let's see some of the practical use case. So we can let me run this. Let me split this window. Right hand side, what we'll do, we'll run. Let me zoom out. trace hyphen I'm using trace tool 2. So this make sure the trace tool is installed. In other terminal, here I will show Atop output. Here you can see the trace command at the bottom section. Look at the CPU section to see the load caused by the trace process. Here you can see it is showing 97% and trace command is using 100%. For memory also, let's close this. Everything will be normal. See, now nothing is in red color. So let's run. This is some basic step I'm doing now to check memory or CPU usage. Bytes I will give 500 MB, and let's give a timeout as well. Timeout I will give 30 seconds. Trace hyphen hyphen VM1 hyphen hyphen VM hyphen bytes space 500M space hyphen hyphen timeout 10 seconds. I'm using this command. Now let's see. This will allocate 500 MB of memory for 10 seconds. Here you can see the memory usage has been increased. Let me run this command once again for 30 seconds, and let me run this is for 2. So let's see how much memory it will be utilized. Observe the mem section. So here you can see CPU usage is also increased. With that, memory usage also increase. Observe the mem section in the system matrix. You will notice the increase in the memory usage caused by the trace process. Look for the changes in free memory and used memory. Let me rerun once again. Here you can see the CPU memory is also here it is showing the memory, and the free memory usage also you can see. CPU load is also increased. You will notice the increase in a memory usage caused by the trace process. Look for the changes in free memory, used memory, and a cache value. Under the process matrix, you can see which process in this case it is a trace process consuming most memory. After test completion for 30 seconds, notice how the memory usage drop back to a normal. So that's it for this tutorial. Atop is a great tool to monitor your system performance and troubleshooting problems. Whether you are logging data for a later or watching live usage, it's an essential tool for anyone managing the Linux system like Rocky Linux or any other Linux distribution. If you found this video helpful, please like, share, and subscribe for more tutorials. Let me know in the comments how you use Atop or if you have any questions. Thanks for watching.